Yay, third time is a charm, right? Um, I tried this video yesterday and the audio was completely foo-har, non-existent, whatever. Technology fails us frequently enough. And I just tried again and my wife came home, so I had to deal with that. So here we are. Let's see. A few days ago, I put up a video about um, what I perceive, a lot of people could perceive as increasing violence in the Earth system. Uh, I made examples of a lot of wind-driven damage, high waves, storm surge, high waves and storm surge not associated with the normal culprits, which are like hurricanes or typhoons or tropical storms, just kind of storms that are so wound up, so severe that they create hurricane-like impacts on land. Um, I mentioned the village of Capitola, not too far from where I live, got kind of sort of wiped out 2 years in a row. People by high waves, they call them rogue waves, meaning the waves are like twice the height of a normal wave, and the normal waves are really high too. So these rogue waves come in, and they're like tsunamis. They have that sort of aspect to them. They're so big that they overwhelm all your coastal defenses that worked for other purposes. Cement barriers and rock walls and things like that. These waves will just go over them, and then they go up. They go up the beach and they go up into the town, and then they go up into the streets, and it can be really, really unexpected and quite exceedingly damaging. So we've been seeing a lot of violence in the system, in the Earth system. Violence. There's nothing else you could call it. Ice shelves being broken apart in 10 days. Huge ice shelves people thought would probably last for 100 years, broken apart in 10 days. And this has happened many times recently, many places. So people are looking at the Earth system and they're asking each other, what's going on here? Have you ever seen this before? What do you make of this? And, there's what we call proximate answers, like, well, there was a really high wave that came ashore. And then there's ultimate answers. Why was there a really high wave? And so we're going to talk about that today. I mentioned, I alluded to some of this in the earlier video, but in the earlier video, what I was really trying to do was just point out the data. And the data is that the Earth system is getting really violent. And violence in your habitat is kind of hard to cope with. We expect things to be normal and regular. Like seasons are fine, and once in a while you get a storm, a hurricane or a tropical storm, and once in a while you get an earthquake. The Earth system, it can do things occasionally, and volcanoes, right? You understand what I'm talking about. Mostly we just kind of go on and everything's fine, and this will be a tragedy and we'll get over it, and we'll bury our dead or whatever, rebuild, and we'll come back, stronger than we were. Fine. What was it? Nishi that said, what doesn't kill you makes you stronger. All right. Yeah. Well, you're going to have a lot of opportunity to test that, see if that's true or not. Okay. Because the Earth system is getting violent. Now, there's a reason why that's happening. It's complicated. If you read the description, you probably left that scratching your head a little bit. It's complicated. Language doesn't really help us here. We don't know how to talk about these things. There's a lot of stuff in science in general that we just don't know how to talk about, right? How long have we been doing science? How long has our language been able to evolve around scientific thought and discussion? It hasn't been very long. So we're kind of not really set up for this. Also, some of the complexity of what's happening is actually hidden in I don't know how else to describe it. I guess the size of the system that we're supposed to be looking at and studying. The system is huge. The Earth is huge. You know that, right? The Earth is huge. It's 24,000 miles around, and it's this big rock, and it's big, and it's so big that there's even different zones. That the poles are different than the equator, right? And there's all these land masses, and all the land masses are different. Some of them don't even touch each other. There's so much room to have enormous continents. The continents don't even touch, right? Um, it's big. It's really big. And you know, humans trying to study something that big, it took us until like 500 years ago even to know how big it was. I mean, the Greeks kind of knew how big it was, but the Greeks didn't know what was on the other side, right? They knew how big the globe was, but they didn't know what was on the other side, or how deep the oceans were, or how high the atmosphere was. And, we just didn't know how big this thing was until just kind of recently. And we're just now beginning to talk about how big it is. We're figuring out how to talk about this thing at almost exactly the same time that it's leaving us behind. I mean, it's going to drag us with it, but this Earth system is going somewhere. And I don't mean that the rock goes around the sun. Okay, it always does that. But this machine that is like painted on the surface of the rock, this machine that has been billions of years in the assembly, that goes through hundreds of millions of years of relative stability. All right. Now that machine coated around the rock itself is on the move. It's on the move. The Earth dynamic system is on the move. My last video talking about violence was preparation for this talk. The violence is there for a reason. The violence is not a one-off. The violence we're seeing now in the system, everything that's breaking up, the huge waves, the long prolonged droughts, the long prolonged heat waves, the intensity of everything, the intensity of the highs, the intensity of the lows, all the violence, all the swings, all the whiplash, all that stuff is actually an indication of something. You can call it violence, but what it is, the violence we're seeing in the Earth system is the language of the Earth system itself, and it is speaking to us. So this is getting all spiritual, right? And crystals and whatever, astrology. It isn't speaking to us because it loves us. It is speaking to us in the same language of, say, the engine in your car might speak to you if it's about to quit. If you've thrown a piston rod and all of a sudden you hear this bang, 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 bang in the engine in the front of your car. Okay, that's your engine talking to you. It doesn't have anything to say, but it's using a kind of language of violence to tell you that your engine just blew up. All right. So again, our words don't really help us here. And these concepts that your engine tries to talk to you don't really help us here. But this is kind of the way we have to approach this. The Earth dynamic system is like a machine. It has moving parts. Those parts, well, they move. So you can see it going from here to there and from there to there. And also there's instruments. We can read temperatures and we can read humidity and we can read the wind speed and we can do all this other stuff. And we can notice that it's talking to us. And what it's telling us instrumentally is that it's on the move. Now, you're not going to hear too many people talk about that. System scientists are fairly rare. I really started my career as a scientist, as a biologist, as a systems biologist. I was doing computational biology. I was looking at whole assemblages. And I was working on a team, and I had to write my own software. The computer software didn't even exist. There were books, huge, weighty tomes talking about how to measure system dynamics, but they weren't doing it on a computer. They were doing it, longhand with calculations. So I had to write computer software to do my own systems analysis. So I have deep roots in this. I was a systems scientist in the realm of biology, but I was a system scientist from the get-go. So I have a lot of time thinking about how systems are constructed, how they are deconstructed, how they operate internally, how they hold together, how they fly apart. And in the last 20 years, I guess, I've been looking at the whole Earth system, the Earth dynamic system, the big system, not just one ecological assembly or one hydrological assembly or something else. Not the cryosphere, not the biosphere, not the lithosphere. I'm looking at the entire rock. Now, the machine in question, the Earth dynamic system, the machine in question is kind of painted. It's a thin layer that's sort of painted on the surface of the Earth rock, right? And it's we because scientists tend to be reductionist and they like to focus on some part of the elephant or another. Then we break it down into domains. So the machine has many layers and they all interact. And some of the layers are called things like the lithosphere, which is the actual rocky substrate, the rock's lithosphere. There's the biosphere, which is the life. There's also the hydrosphere, all the water, mostly the oceans, of course, but also the lakes and the rivers, and really to some extent the rain. The atmosphere, which is complicated. It has its own layers, right? From the part that interacts with the surface of the Earth, right on up through the other layers to the top part of the atmosphere that interacts almost entirely with space, and uh, the cryosphere, which is frozen water, so solid water, as opposed to the hydrosphere, which is liquid water, water in the liquid phase. And the cryosphere is water in the solid phase. Okay. And we only have a cryosphere because we happen to be in an ice age, a series of ice ages, glacial epochs. More about that in a minute. And so all these painted on surface manifestations of the rock. Okay. These surface manifestations are each of them very complicated. Uh, Even the lithosphere is very complicated. You think, oh, that's the surface of the Earth. That's the rocks and the asphalt and the concrete. But it also has layers, right? It has layers. And if you know your geology very well, then you know that there's the crust and the plates interact with each other at their boundaries, and one plate will go onto another, and you get earthquake zones and you get volcanic zones, and there's different types of faults, thrust faults, slip faults, and all that kind of stuff. And then the layers of the lithosphere, the mantle, the core, the whole thing. And you could spend your entire career studying just the lithosphere or studying just the cryosphere or studying just the biosphere and never really get into the others. You don't have to. You can find a rewarding career, very interesting, meet great, interesting people, do interesting work out in nature, and write papers and get paid. Of course, that's what a career is for. We do the research. We get paid to do it. You can teach, right, and never leave your lane, never leave your sphere, and that's fine. Yeah, you can do that. And these people will talk about their work in great detail and with great excitement. And if you're familiar at all with the area of work that they do, then you'll find it interesting and you'll learn something. But it's never the whole picture. It's never the whole picture. So when I'm watching the drama, the pageant of climate change and global heating playing itself out across the media and the news and the scientific literature and the discussions and the IPCC process and the COPs. And as I watch this pageant, this drama play itself out, of course, I am constantly aware that there are people who are talking about their individual sphere of interest, and there's not really a lot of talk about how all these things integrate. The Earth dynamic system is an integrated machine. I'm calling it a machine because I don't know what else to call it. Uh, if we were being religious, we would call it what? Gaia, a spirit, right? The spirit of the earth. Well, I'm not going to do that. So I'm going to call it a machine. There are parts, the lithosphere gears with the hydrosphere, and the hydrosphere at the same time is gearing with the atmosphere, and the atmosphere and the hydrosphere together are geared to make the cryosphere. And all these gears are intermeshed, and they're all turning, and they're all driving each other, and parts of the machine are driving over other parts, and sub parts of the machine are driving under others, and the whole thing operates on the surface of the rock, on the surface of the lithosphere, the Earth, the actual Earth itself. Not the Earth, the dirt. I mean the Earth, the planet. Earth with a big E, okay? Capital E, Earth. So all these elements are present on the surface of the Earth. They're all present in connection with each other. They're all geared together in different ways. They're all geared, some fast, some slow. Changes in the atmosphere can happen by the minute. A tornado can spin up in seconds. And other things like ocean currents change hardly at all during human existence. And we don't even know why we study them, right? It just never seems to change. And yet, all these things are geared together. And it's like a machine in that regard. If you accept my description that all these components are geared together, that it's like a machine. It's like a clock, I guess, or some other machine that has gears, right? There's lots of different types of machines that have gears. This machine has no destination. It's just how energy works itself through all the different spheres. I had another thought. I'm not going to bring that up, though. It has to do with music. Random thought. Has to do with music. The music of the spheres. Look it up. The music of the spheres. So all these things are geared together. Energy is pouring through the system. The energy ultimately comes from the sun. It ultimately accumulates in the atmosphere due to the greenhouse effect, which is a real thing. And because there's energy accumulating, it moves through the system, turning gears as it goes. And it forces these systems to interact. Heat in the atmosphere due to the greenhouse effect, which is an atmospheric phenomenon, component of atmospheric physics. The heat in the atmosphere transfers to the oceans. And then the oceans warm up initially on the surface, but eventually deep because the currents transport surface water to the deep. And somewhere else, the deep water transports to the surface. So the heat is distributed in the ocean slowly, but the greenhouse effect heats the air, which then heats the ocean. The ocean then evaporates, putting moisture, water, in the vapor phase into the atmosphere. So now they're feeding each other, right? They're feeding each other. Moisture into the atmosphere. That moisture is transported over the land by winds, where the winds come from, but it's transported over the surface of the sea and onto the land with winds. It then falls, hits the ground, the lithosphere, runs across the ground back into the sea, carrying minerals and dirt and plant material and all other kinds of things. And so that there's now you see there's a little cycle here, right? Evaporation over here, transportation, precipitation, and then another type of transportation across the ground. And so all these things are geared together. Some of them are fast, some of them are slow. Energy drives the entire system. It starts with the sun, moves into the greenhouse effect, and from there it transfers energy to all parts of the machine, the Earth dynamic system. It is dynamic because it's always in motion. I mentioned that in the last video. The Earth dynamic system is constantly in motion. Even the rocks move. The rocks move. They don't have a plan. They don't have a destination. They move nonetheless, okay? The whole thing is in motion, and that motion is driven entirely by the sun. Entirely by the sun. Secondarily, through the greenhouse effect. The greenhouse effect is how the Earth captures energy that then drives all the gears. If something were to happen to the sun, if the sun were to wink out one day and go dark and just stop being a sun thing, then the Earth system would, grind to a halt, probably pretty quickly. If the sun were to suddenly flare up and become brighter, the Earth system would have to react to that. Water would boil away from the oceans. Rains, the atmosphere would become saturated with moisture. Rain would never fall, because it's too hot for the rain to condense and fall to the land, and so on. So right now, given the sun's behavior and its output, it varies a little bit, but it's pretty much stable, has been stable for billions of years. Something to be thankful for, right? With the sun being constant and the Earth not changing much, although it does change, so that's can be really critical. The Earth not changing much, and the sun not changing much, then the whole system kind of grinds along. It kind of grinds along. And you get seasons, and you get climates, and you get growing zones, and you get rivers that flow regularly, and you get rain patterns that you can kind of predict. And the Nile floods on a particular day, and they built their entire Egyptian religion around the Nile flooding on a particular day. I mean, this is kind of all kind of sort of predictable, not entirely, because sometimes places, areas that were growing zones become deserts. Sometimes humans do that. Sometimes humans screw up. They screw it up, and a place that used to be a lush growing area becomes a savanna or a desert. We can do that. We've done that in the past. We're doing that in the Amazon right now, in case you didn't know. The Amazon is at risk of becoming a savanna because of us. We're doing that. Now, the people who are doing it will claim, no, we didn't do that. Well, yeah, you did. So the system kind of moves along in its pace because everything is equal, and then we can disturb it. Now, most of the disturbances humans have been doing have been fairly small scale. Even turning the Amazon rainforest from being a rainforest into being a savanna, which is more dry and temperate. Temperatures vary with the seasons and some other things. That's small scale. Converting the Amazon to a temperate lowland is actually pretty small scale. That's big, as humans tend to do things, but it's still small scale. If you want to understand large scale, then you have to go to global scale things. And here, this is where I have to talk about, of course, global heating. I call it global heating. I don't call it climate change. Now, when we cut down all the trees in the forest, in the Amazon rainforest, then that climate will change. That climate will change into a savanna. It's very different rainfall regime, very different soil moisture profile, very different plant assemblage, animal assemblage, very different seasons, and so on. So you can have climate change, and global heating is going to cause climate change in many places, maybe not all places. Climate change is not global. Climate change is not global. It's regional. And some climate change we cause directly. Cut down all the trees, you got some climate change on your hands. Okay. Global climate change simply means that lots of places on the earth are going to see some climate change. Some places won't see any, or nothing noticeable, or nothing that you couldn't deal with. What's happening globally is global heating. That is happening globally. There's no part on the planet that isn't heating on a larger time scale, like 5 years or 10 years. You can have local dips in average temperature, but the trend, if you plot the data and you look at you draw a line or you draw a curve, it's up. The temperature variation on the Earth is not around some stable equilibrium. It's going up, and you can not believe me, and that's fine. You believe in anything you like. I don't even really care. I'm not here to educate anybody. I'm here to explain things to people who want to understand. So while there is global climate change, that's weak sauce. That's not what's happening to you. That's not what's happening to your Earth system. And that's not, calling it climate change is not going to help you deal with what I'm going to talk about next, which is crack up, boom. Crack up, boom. The global system is atomizing. The Earth global dynamic system is atomizing. It is breaking itself apart. It is going to become mobile, and the machine is going to move. It's going to flow. We think of machines being made out of metal, and they're rigid, and the teeth on the gears come together like this. But there are metals that at room temperature, for example, are a liquid, and the Earth dynamic system is in the process of liquefying. That's what it's doing. All the things that were supposed to be stable and never changing, and maybe you get some seasons, and maybe you get a storm or a hurricane once in a while, all that stuff is going to turn to liquid. Now, the way you will see that happening, and the type of and the liquid I'm talking about is not liquid water or liquid mercury. What I'm talking about is fluidity, the protean nature of dynamic systems. They only seem to you on the human time scale, maybe the civilizational time scale, they only seem static. They're not static. They're fluid. They're fluid, and they can move. And sometimes they move slowly, and sometimes they move just kind of back and forth like a pendulum across, across some narrow set of extremes, and basically around some minimum, some mean, some average. They oscillate back and forth, but they're fluid. You see, they're doing this. They're not here. They're never here, as opposed to over there. They move. They move. The Earth dynamic system, all the things you could point to, all the spheres, the lithosphere, the hydrosphere, the cryosphere, the atmosphere, they move. Okay, they're moving relative to each other. And when I said that, they're geared together, but the gears themselves, the number of teeth on the gears change sometimes, and sometimes the gears, it shifts gears, and these two used to interact, and then there'll be a whole nother set that interact. It's a dynamic system. It's called the Earth dynamic system. It's fluid. It's fluid. And when we see all this violence taking place, this is a signal. This is a kind of language that the machine unknowingly, because it has no mind, but what the machine can signal to us if we are sensitive to how it operates. If you want to look at it and become familiar with its operation as a metaphorical machine, then you will listen and you will see signs. Okay? Like with any other machine. You'll notice, that's not right. When did it start doing that? Hold on. Did you see this? Is this changed? I think this has changed. Is that changed? Okay. When did this change? Bring me some data. Okay, here. It's all going along like this, and that's fine. And then it does that. Wait. What's going on here? Okay. Why did it do that? Is it coming back up? No, it's not. It's staying down here now. It's going along like this. Why? Why is it doing that? If you're sensitive to the machine and you become comfortable with it and familiar with it, and maybe even in your mind it's sensible or predictable on some abstract level, you'll notice when it breaks. I'm using language here. It's not the best thing, but this is all we have. All we have is language. So I'm using language. What's really happening is that this machine, this self-made machine, this self-correcting machine, this self-assembled machine called the Earth dynamic system, it is insanely complicated. And by complicated, I don't just mean there's an insane number of gears. There's a lot of gears. There are billions of gears. And I don't even mean there's billions of people. I mean there's billions of gears. There's tens of thousands of deserts. There's hundreds of oceans and bays. There's dozens or even 3 dozen ocean currents that have been named and studied. Okay, there's so many parts to the system that even if you're a systems scientist and you spend all the time learning all these things, and you know all the names of all the currents and all the names of all the bays and all the names of all the glaciers and all the names of all the layers in the atmosphere, and this layer blows this way and that layer blows that way, and sometimes they interact and you get a weird thing happening here. And even if you know all that, and it's hard to know all that because there's a lot to know, right? But even if you knew all that, you wouldn't know even one billionth. There's a billion more things you would need to know. There's all kinds of emergent properties that we barely comprehend. There's things we can't see, like parts of the atmosphere and which way they move. We infer them with radar and weather balloons and some other things. There's all the changes that are taking place, forests becoming savanna biomes and wetlands becoming dry land, and dry lands becoming wetlands, and there's all these movements, and just about the time you think you got it figured out, there's another thing pops up, whack-a-mole style, and this whole thing, it exists. It doesn't even exist in 2 or 3 dimensional space. Most people see the world, the earth around them, in really 2 dimensions. They know their streets, and they know where the neighborhoods are, and they know that they live kind of here, and there's a school kind of over there, straight out that way, not up there, but not down there, over there, right? Straight out. It's like 2-dimensional. It's like everything's playing out on a tabletop. And even if you have to drive over a mountain to get to another place. You don't see that in 3 dimensions. If you look at the map, it's still 2 dimensions. There's a freeway and a highway or whatever, and it winds along like this. Well, meantime, you're going to be going up a mountain, but you don't go up the mountain because it's your car that's going up the mountain. You're just sitting in the car, and you're going to have an exit, you're going to have an on ramp or whatever, and that's all you see is how these things intersect with each other. You don't realize you've climbed 3,000 feet. Now you're on top of a mountain. Okay, you don't know that at all. You don't even care. Never occurred to you. If you were pushing a cart up that mountain 3,000 feet, you would certainly know. People used to be more three-dimensional, and they avoided mountains and they avoided canyons for a good reason, because they couldn't cope with it. You can cope with it just fine. So you're two-dimensional. Most people live their lives in 2 dimensions. That's it. Now, if you're a pilot, or I guess a pilot is about it. Pilots, of course, go up and down all the time. Pilots have to think in 3 dimensions. They do. Yeah, there's the 2 dimensions of where things are. There's this airport over here, and there's an airport over there, and I have to cross from one point to the other point over here, and they're separated by distance. And if I were on the ground, I could do, as they say, as a crow flies, I could do that distance. But now you're a pilot and you're piloting a jet. So what does the jet have to do? It has to take off. It has to climb to an altitude. And now it's at an altitude. Oh, and by the way, maybe you don't know this, but jets have to fly at different altitudes depending on which direction they're going. It's like lanes on a freeway. And air traffic control will tell you have to be at this altitude, and now you have to be at that altitude. And to approach this airport, you have to approach it from a certain direction, and starting at this altitude and ending at this altitude. And they have to tell you all these things. It's all this three-dimensional math. So pilots live in 3 dimensions just to do their work. How many pilots do you know? How many pilots even talk about this? They're the only ones to do this. Really, they're the only ones to do this. Most of us live in 2 dimensions. Now, the Earth dynamic system is like everything else in the universe. It exists in 4 dimensions, the fourth dimension being time. It does matter because when you have oscillating components of the Earth dynamic system, like the seasons, for example, then those take place over time. So time is an element. And if you're going to be a system scientist and you're going to study the Earth dynamic system, then you suddenly become like the pilot who's embedded in height just to do their job. An Earth system scientist gets embedded in time. Time. Things play out over time. So already this is getting weird for most people, right? Now you're talking about time. Now you're talking about the past and the future and how far back in the past and all this kind of stuff. This is where people get blindsided, because now I'm going to tell you something that you've never thought about. Ever. Not in your entire life. You've never thought about this. Probably. I mean, it will be very few people who have ever thought about what comes next. When I say the Earth dynamic system is on the move and it's going to liquefy and flow into a completely different dynamic equilibrium, okay, that's not happening in 2 dimensions, like a river will flow down a landscape. It's not even happening in 3 dimensions. It's happening in 4 dimensions. And in fact, it's happening in, I don't even know how many dimensions. The Earth dynamic system is a multi-dimensional system. I'll just take a wild guess. It has 100 dimensions. 100 dimensions. Most people can't even think outside of 2. The Earth dynamic system probably has 100 dimensions. And within those, spread across 100 dimensions, probably in mathematical phase space, spread across 100 dimensions is probably, and if you're a mathematician, talking about dimensional math is trivial. They do this kind of stuff all the time, right? It's not a big deal at all. They do higher level dimensional math all the time. All kinds of tricks to do that. It's just math. But the Earth system is a machine with gears and overlapping spheres that operate in probably 100 dimensions. I don't even know how many. It could even be a million. Dimensions, not layers, not physical layers like the atmosphere has 9 layers or something. Dimensions, not 2, not 3, not 4, which you could barely comprehend. 100 dimensions. And in those 100 dimensions is probably 100 billion variables of consequence. 100 billion variables. Humans cannot comprehend this. We can't comprehend it. We can talk about, we can do weather analysis. And weather analysis, by the way, is multidimensional. When they're doing weather forecasting for you, they're using supercomputers. Okay, weather forecasting used to be almost impossible before the invention of supercomputers. And you know why they're using supercomputers? Well, one thing, there's a lot of data to crunch, but also it exists in multiple dimensions. It's hard. They're doing matrix math, doing matrix algebra across dozens of dimensions. It's hard. The only thing that turned out to be harder, and I'll kind of mention this in passing because it's slightly related. I mean, I can sense how it's related, is the recent excitement about the emergence of AI, artificial intelligence, or AGI, artificial general intelligence. It's crashing upon the scene of the human experience, and it's going to change everything forever. And I don't know what to say. The reason I'm mentioning it here is because our current AI approach, which is turning out to be spooky amazing, is based on what they call large language models. Now, people have consistently failed to understand what a large language model is. What it is, it's a gigantic, multi-dimensional. The number of dimensions are huge. I saw they're tracking like trillions of parameters and across millions, or is it billions of dimensions? It's nuts. It's completely unhinged. Now, of course, no human is doing this. Is all being done with the computers. It's being done with supercomputers. It's being done with entire arrays of supercomputers. And what they've come up with is essentially an artificial mind. And the artificial intelligence they're talking about now is an emergent property of this massively multidimensional thing. And people get all confused and they say, well, it's just doing word prediction. No, it isn't. System scientist here. No, it's not. That's not what it's doing. It is not just predicting the next word. It's not doing autocorrect on steroids. No, it's way past that. It may not be as good as the human mind, but it's getting close. And the point is, it's a massively multidimensional construct. And since we're on a tangent here, it constructed itself. People don't understand it. There are no AI programmers anymore. They don't even understand these things. They can't tell you how they made themselves. They can't tell you how it was created. And they're promising we're going to control it. They're promising all these things, and that we understand it. They're full of shit. They don't know what they've got. They don't know what they're dealing with. And the same thing applies to climate scientists. They're grappling with this thing. It spans hundreds of dimensions, and it's got trillions of parameters. And they're looking at one little thing, and this scientist is looking at that little thing, and the instrumental record, the temperature, the humidity, the wind speeds, you can instrumentalize that stuff. But that's not what it is. It's a machine, and it's got hundreds of dimensions in flight, and it's got billions of parameters. At least it's probably it's probably a number that can't even be discussed. The Earth dynamic system. It probably has so many dimensions and so many numbers, so many parameters that can't even be discussed. And I think about that when I think about the LLMs that are generating artificial symptoms, signs of artificial intelligence. Yeah, it's the same thing. These are systems we will never comprehend these things, never. And they're making themselves. And the Earth dynamic system made itself. It built itself. Now, it is on the move. We know it's on the move. It's speaking to us in the language of motion. And the language of motion can be summed up as violence. The Earth dynamic system is moving, and it's doing so violently. And the violence to something as big as the Earth is actually quite small. But when humans and ants and elephants and giraffes get in the way, it seems like a big deal. So the violence to us is a big deal. But to the Earth, it's nothing. Rogue waves coming ashore in California is nothing at all. It's just violent. And to creatures on our scale, it's fatal. and destructive and FEMA and rebuilding and whatever else, right? Or moving, right? Maybe we can't rebuild anymore at some point. So where is this system going? I've heard people say things like, the earth hasn't been this hot in 20,000 years, or the earth hasn't been this hot in 120,000 years, or the earth hasn't been this hot in 20 million years, and they're trying to say something about the earth system. They're saying it's getting hot. But what they're also doing is they're adding another layer. You see what was in common with all those things? It's time. Time. And most of this would qualify as deep time. For most people who barely know anything about, say, ancient civilizations, anything more than 100 years back is essentially prehistoric time, right? Stone Age time. We go from, our great grandparents to Stone Age, most of us. And it's just completely incomprehensible that this Earth system has features, has existence 20 million years ago, 200 million years ago, 2 billion years ago, deep time. And when they say things like, well, the Earth hasn't had this much carbon dioxide in the atmosphere in 3 million years, or the Earth hasn't been this warm in 3 million years, or the Earth system hasn't looked like this, whatever that means, since 3 million years ago. It's hard for people to comprehend what that means, because that's time, and most of us live in two-dimensional space. At most three. Seldom do we include time in nearly anything. And yet this discussion now has to talk a lot about time, because the Earth dynamic system is on the move. And we know it's on the move because it's becoming violent. And that's the only word I can really apply. It is pumping up with energy. It is atomizing. Everything we thought was stable and eternal is not. And the whole system is falling apart so that it can move. With all these spheres and all these gears and all these dimensions and all these parameters locked together, turning together, when it has to move, all that has to unlock. It has to delaminate. It has to fall apart. And then when it's in a more fluid state, it kind of rolls along the multidimensional landscape, tries to find another space in phase space, which plays itself out in 7, 8, 10 dimensions, right? It rolls along until it finds another stable equilibrium in phase space, and then it reassembles itself. That's how it works. It sounds science fiction, it sounds crazy, but that's how these systems work. That's how they work. When the Amazon rainforest becomes a savanna, there's a series of falling aparts and rebuilding something else. There's a process of one thing dissolving, literally dying and being decomposed. There's an aspect of the Amazon that dies and decomposes, and from those ashes, if you prefer, a new thing is created. It's the same coordinates on the land, right? It's the same latitude and longitude. And it's, the atmosphere is still there, and the lithosphere is still there, and the rocks aren't changed. And yet something that had been there for millions of years fell apart, dissolved, died, decomposed, and then reassembled itself as something completely different called a savanna or a grassland. That's what happens. I'm not making that up. From a systems perspective, now, if you're a botanist, you're going to say, well, this plant disappeared. This plant came in. This animal, maybe even these 2 or 3 animals that are dependent on each other, they disappeared. But then there was another set of animals that formed a completely different biosphere, and they came in. And you'll look at that, and you'll look at this, and you'll have data, and you'll have tables of all the different species and whatnot. But a lot of the time, people will never connect. What happened? Well, what happened was the system that existed before atomized. Now, you could call that dying, decaying, scattering, whatever you want to call it. Nevertheless, it atomizes. Literally, it becomes atoms, molecules and atoms. And then slightly later in time, time goes by, later on, it reassembles itself as something completely different that is more in tune to the phase space that it finds itself occupying. So that can happen in the Amazon and people completely miss it right over the head. Boom. What just happened? I don't know. Now there's a savanna. Okay. It moved. The system moved. It looks different. And there was a series of violent events in between, extinctions and immigrations and invasions and all these things that had to happen. And there were fires and there were whatever else. And one system was destroyed and another one came in to replace it. And there was a certain amount of violence over time. And now we have a new equilibrium. And that's what's happening to the Earth dynamic system. The Earth dynamic system right now is atomizing. It's atomizing. It's becoming a liquid of a kind. And that liquid exists in multidimensional space. It is billions of parameters in hundreds of dimensions. And that whole system, all the gears are ungearing. Okay. All the layers are delaminating. And the whole thing is turning into liquid of a kind. It's a multidimensional liquid. It's a superfluid. It's a hyperfluid. It's a something. Words. I don't know. What are the words? I can't find the words. It turns into a hyperdimensional fluid. It moves. It flows downhill like any fluid would. And it flows downhill until it finds a relative stable saddle and it reassembles itself. Now that sounds hokey, right? That sounds stupid. How can an entire planetary system do that? Well, that's what it does. That's what makes my life so difficult. I know these things. And I know we are verging into that because the first sign in the language we can use that this system is atomizing in preparation for a move to another dynamic equilibrium, which it always is violence. Yes, it's going to be ugly. It's going to get ugly to us little puny living organisms who really, if you really come down to it, rely on stability. We need things to be stable. And so when things are not stable anymore, when things are, what should I call it? Oh, I know, on the move, when things that used to be predictable and sacred and eternal aren't eternal and they're moving and you're like, whoa. What do you call that? I'm calling it violence because that's how it's going to look to us puny ant-like creatures. It's going to look like violence. Waves and storms and hypercanes and hurricanes and named storms and floods and storm surges and biblical this and four horsemen of that and all this other stuff and, rapture and whatever else you want to apply to it. Okay. It's going to look violent, in a word, violent. It's going to be violent. We haven't seen anything yet. These are just opening days, people. Opening days. And I don't know what to tell you. It's moving in phase space, which is multidimensional. The one dimension that is going to help us here is time. It's fortunate that we can look back in time to earlier versions of the Earth dynamic system, and we can locate there earlier iterations of this machine that we are so useful now being the way it is. It has changed in the past to bring us to where we are now. Most people don't know this, but the Earth didn't used to have ice on it to speak of. Not really. It was pretty much the same temperature from the pole to the equator to the other pole. The pole still had long days and long nights, meaning the day lasted half the year and the night lasted half the year. So you had to cope with that. But the temperature regimes, they weren't that different. You go to Antarctica and you can find petrified forests. Tree stumps and that have turned to stone. Okay, there are coal seams. Coal comes from plant material, forests and swamps and things like that. That's how you get coal. So you go to Antarctica, you can find coal seams, and they've known this for hundreds of years since they've been exploring the place. There's petrified forests and there's coal seams. It wasn't always covered in ice, and there'll be a time in the future when it's not covered by ice again. Same thing with Greenland. Greenland's covered with ice. Well, there was a time when it wasn't. Uh, the North Pole is a polar sea, but oh, guess what? If you go to the North Polar Sea and you ignore the ice or you get under the ice or whatever, there's natural gas deposits and oil deposits. Why do you think we have all these oil extraction efforts in Alaska? That's up around the Arctic Circle. Well, there used to be plants up there. It wasn't that cold. It just wasn't. In fact, the ice ages, the epoch of ice, is about 3 million years. 3 to 5. I've seen different numbers. There has been a secular cooling of the Earth for about 20 million years. But prior to about 20 million years ago, the Earth was hot compared to what we're used to. It had a lot of carbon dioxide in the air, and Earth was hot. And the seas flowed differently than they do now. The continents were smaller because the seas were deeper and they occupied more of the landmass. There were continents that are connected now were not connected back then. They were more like islands. Like Australia is a continent, but it's also kind of an island. And so South America was an island, and North America was an island, and Africa probably had no connection to Europe, and so on. India was its own continent, hadn't really run into Eurasia yet. And there's a lot of land masses. There was a lot of water flowing around them. The water dominated, and it was some 270 to 300 feet deeper than it is now. Right? So that was 20 million years ago. Now we're talking time. We're talking time. And what's happening with the Earth dynamic system right now is that part of its atomizing and turning into a liquid and flowing is that it's not just flowing across the landscape. Now you're talking 2 dimensions and 3 dimensions. That's not where it's happening. We can see it manifest in violence across the landscape, but that's not where it lives. That's not where it's flowing. It lives in 10, 20, 50 dimensional space. And it's flowing through this landscape of 50 or 60 dimensions, however many it is. It's huge, okay? And it's flowing through this landscape. And just like a river flowing through a 2-dimensional landscape, this thing is flowing through this multi-dimensional landscape. And the way it manifests to us is that it's going backwards in time. It's going backwards in time. Now, this is critical to understand. The period of ice that we evolved in, the 5 million years that humans have been evolving from apes, right? And, actual humans have been around for either 200,000 years, or I heard recently 300,000 years, and primitive proto-humans, other types of Homo, not Homo sapiens, but Homo neanderthalis, Homo, pulling a blank, I'm tired. Other genus Homo, go back even further than that. Neanderthals go back a million years, right? So humans have been evolving, but that whole process started really during the ice ages, the 5 million years or so that the Earth has been in a dynamic equilibrium that was colder and, frankly speaking, dominated by ice, the cryosphere, not the oceans. I mean, oceans are really important, but I would have to say that the Earth dynamic system that we live in today is dominated by ice. We are currently, our civilizations, and I mean, going back 18,000 years, right? We've had many civilizations, Aztecs, Minoans, whatever. 18 million years of doing civilization, okay, has all been in one period between the glacial epochs. It's called an interglacial. It's been suspiciously stable, by the way. They usually don't last this long. Maybe we could have done this civilization thing earlier if we'd had more time. This time we had more time. Again, time thing. You see this time thing, how this works? No one thinks about this. But this is where it plays. This is where the Earth dynamic system is in motion. It's playing out. It is moving and playing out in time where we don't even exist. We have no comprehension of time. Yeah, I know you wear a wristwatch, but you have clocks all over your house, right? Most humans have no conceptualization of time outside of appointments. But if you understand deep time and you understand anything at all about the Earth dynamic system, you start to run it forward and backward in time. And the changes that are taking place in the Earth dynamic system right now are running it Of course, it's going to go forward, and we are going to go forward with it. If we don't go extinct, we are going forward with it. But its forward motion in time is actually retracing a backwards in time to a prior time. It can do this because it doesn't have wristwatches and clocks. It's just a multi-dimensional machine that, that because of the gearing can run forward and backward in time. And it is now running backward in time. It's going forward with us, or maybe we are going forward, and that's our interpretation of what this machine is doing. We understand enough about time to think that time only goes forward. Okay, but the Earth dynamic system has no such conceptualization. It is in fact running backwards. It's running backwards according to time, in time, and it's going back to a period that is probably what, 20 million years in the past. 20 million years in the past. So, okay, so now we get to ask ourselves a question. Maybe there's a couple of questions and they're interlinked. What does it look like when the Earth dynamic system starts running backwards in time? I've already introduced the term. It looks violent. That is how, I don't want to use the word time travel, but this is a multi-dimensional machine. Time is just one dimension, okay? So I push my chair back, I'm moving backwards in chair space, okay? No big deal, right? Now I can move forward in chair space. The Earth dynamic system moves forward and backward in time. Time has no meaning. It's just a dimension. That's it. It's just a dimension, and it doesn't care what time it is. Well, the Earth dynamic system is now going backward in time. Why? Because we're heating it up. And what difference does that make? That's going to melt the ice. And without the ice, the Earth starts to change. It atomizes. It starts to flow through time to another earlier state where there was no ice. Okay? And that earlier state lasted, what, 400 million years? You think you've got some stability now with your 18,000 year long interglacial, oh, doesn't our cat have a long tail? The Earth dynamic system has known hundreds of millions of years of relative stability, but it was warmer. It's very easy for it. If we heat it up using CO2 emissions and methane emissions into the atmosphere, enhancing the greenhouse effect, melting the ice, what we're really doing is we're driving the system backward in time. That means something to us because that doesn't sound possible. It means nothing to a multidimensional machine being driven backward in time. Whatever. Now I'm going backward in chair space. Now I'm going forward in chair space. It's as easy as that. Okay. Time is meaningless to a machine like this, completely meaningless. And that's why we're kind of screwed. We're kind of screwed because now the second question is, if we are able to drive the Earth dynamic system backward in time by just heating it up, because that was an earlier state, that was an earlier equilibrium state that lasted a long time. It kind of, you could even say it likes that state. It doesn't like anything, of course. It doesn't have any intelligence and preferences, but it was stable for a long time. Though that was a stable state. It liked that state. Okay. So if we're going to start heating the planet up, then guess what it's going to do? It's going to remember, okay? Because remember, I'm asking you to remember what I just said a minute ago, that the planet remembers phase spaces. And that is that the phase space where it is warmer than it is now, and there's more CO2 in the atmosphere than there is now, that phase space, it has already occupied. It can go back there real easy. That's a comfortable pair of shoes. It can get out of these shoes and put those on real easy because it's already been there. It's already been there. And so if we start heating the planet up and we start pouring CO2 into the atmosphere, we start screwing around with this machine, it's going to wake up. And it's going to say, oh, yeah, I know what this is about. Oh, let me stretch myself out here a little bit. Okay, so we're done with ice ages. All right, that's fine. This kind of sucked anyway. And it'll just go. Boom, it'll go. And what the going looks like to you, it doesn't look like packing your bags and getting on the airplane. That's how you interpret going somewhere. When the Earth dynamic system goes somewhere, the only part of that you're going to see in your puny 2 or 3 dimensional space, okay, is violence. I keep coming back to the same thing. I keep coming back to this because that's all I've got. That's all I've got. It's on the move. It's going someplace where it has been real familiar. That's a phase space that it occupied for a long time. It fits nicely. Okay. And, the last great race that occupied the Earth during that earlier phase space that lasted 300 million years were the dinosaurs, right? The dinosaurs. They were there for, what's the number, 150 million years? Something like that. Yeah. And of course, before that, there was the reptiles and the amphibians and, these scaly creatures that finally gave rise to mammals, over time. Uh, they've been around a long time. The Earth was very comfortable with them. They were very comfortable with that earlier iteration of the Earth in the dynamic system. And we are sending it back there. And it's quite happy to go. It's like, oh, yeah, I remember that. High CO2, high greenhouse effect, high temperatures, no ice. Oh, yeah, I'm all about that. I am all about that. And it's going to go there. Now, what did that look like? Well, not my domain. I'm not a paleoclimatologist. I can say a couple of things about it. Well, it must have been very productive and very fertile in its own way, because it was able to feed a set of animals that, by our standards, were simply enormous. These are ginormous animals, and there must have been lots of food for them to eat. And the herbivores were enormous, and they ate a lot of food. And you could probably look up the numbers. How many tons of food does an elephant eat today? Okay, well, how many tons of food does a diplodocus eat? Okay, it's a bigger number. And then, of course, the carnivores were huge because the herbivores were huge, and the carnivores had lots of herd meat, and the carnivores were enormous, and there was lots of them. And by those standards, our little, poor little sad little ice ages, there's nothing in comparison. So the Earth was very capable of producing life in those earlier uh, system configurations. I guess that's the way I can put it. It was much more productive. Lots of big animals, lots of diversity. And, we, like it or not, maybe it's a good thing. I don't know. Maybe it's a good thing. We are sending the Earth dynamic system back to that phase. Now, again, we're not traveling backwards in time. We're traveling backwards in phase space, of which time is a single dimension. And it's no more meaningful to this multidimensional machine than me moving my chair backwards on the floor. Okay? How meaningful is that? It's not meaningful at all. I go forward, I go backward, whatever. I just translate across the axes. It's no big deal. The Earth dynamic system is going backwards in time. It's translating across time. It is going into an environment where it was very stable for a very long time, was highly productive, huge numbers of species, enormous individuals within species. And there was no ice anywhere. So the entire surface of the Earth was productive, no ice. You can't grow much in Antarctica now, but in 100 years, you certainly will be able to. So the whole planet's surface was productive. The water was even more dominant than it is now. Water was less segregated into ocean basins than it is now, because the continents didn't connect with each other the way they do now, because the sea level is so low, and so on. So that was a long story, right? That's a long story. It started with my last video where I was talking about the meaning of the violence. What does the violence mean? There's a lot of it. There's going to be more. And if everything I just alluded to, that the system is on an excursion, it's going somewhere. It is doing this in multidimensional phase space. Time is but one of the axes across which it can translate. And the axis of time that we are driving it down is into the past, because we are reproducing conditions of CO2, atmospheric greenhouse gases, and resulting global temperature, and the lack of ice, and a bunch of other changes in the various spheres that are going to be reflective of what things were like 20, 80, 100 million years ago. A planet that would be familiar to dinosaurs. And a lot of other species that lived at the poles, for example, and don't live there now for obvious reasons. And the occurrence of all this violence informs me that that's what's happening. The violence in the Earth system is not a thing by itself. It's what you see. It's a projection into our puny little two-dimensional existence. It's a projection. It's the shadow of a complicated machine that lives in many dimensional space with billions of parameters all interacting with each other. And the shadow of that, it projects onto our puny, impoverished two-dimensional existence is what we call our climate. It's the climate. It's the seasons. It's the growing zones. It's you plant at this time of year, and then the rains come on a certain pattern, and then the harvest happens here, and then the winter comes, and we pattern our existence and our politics and our migrations and everything else around this, what's just a shadow of an enormously complicated machine that's grinding away in its own phase space, completely oblivious to our existence, that we are even here trying to interpret everything that's happening. And while we've been dinking around with chemistry, and setting things on fire and digging them out of the ground and setting them on fire, and boosting CO2 levels in the atmosphere, enhancing the greenhouse effect and melting the ice and raising the Earth's average temperature while we've been just dinking around like a bunch of 2-year-old toddlers, stacking our little blocks. Okay. The system is remembering. Not too far away in phase space, there was another dynamic phase that it existed in for hundreds of millions of years. It's remembering. We are waking it up. We are stirring it out of its slumber. I'm using words. I am at a loss for words, lapsing into poetry. Okay. We are waking it up. It is now turning into a fluid. It's becoming fluid. And once it's fluidized, it can start to flow across the landscape. It knows that landscape. It's flowed through this landscape many, many times. It's had 4 billion years of flowing across this multidimensional landscape, in and out, forward and backwards. Okay. And finding a better place, and then moving out of it and finding a different place and sitting there for a while and then pulling back. And I'm doing this in 2 dimensions with my hands, right? I'm saying it's going this way, it's going that way. I can move my chair back and forth, okay? Okay. But that's because I'm stupid. I'm just an ape, okay? I can only comprehend things in so many dimensions. This thing is a multi-dimensional monstrous machine. And it remembers everything that ever happened. It exists in every phase space that it ever could exist or ever might exist. It's all there. It's already there. It's already programmed in. And we are pushing it into the next one with our CO2 emissions, which enhance the greenhouse effect, which melts the ice and changes the water cycle and wakes up the Earth dynamic system. And it starts looking for another part of its multidimensional landscape that's more comfortable giving all of this new input. It's on the move. It's already on the move. The entire system is on the move. And your only experience of that, with your puny little monkey mind scurrying around looking for another banana, your only experience of this multidimensional system churning and grinding and liquefying and moving across its landscape of 50-dimensional phase space, your only interpretation of that, the only thing you will ever experience of that entire shit show as it moves back to its old home, will be violence. Lots of it. And it's the kind of violence that can drive entire species assemblages to extinction. We're not talking just little bits of violence. The violence can be absolutely mind-numbing. And we did this. And you might say, well, we can't do that. We're not big enough to do that. Well, you know what? Here's some news for you. where the system is now is not where it wants to be. It's only been here for 5 million years. It got pushed into it over 20 million years. It has 500 million years of experience being where it wants to be and where it's headed now. It finds that state attractive, and it is being attracted to it. And we have woken it up and reminded it that there is another slot, another landscape in phase space where it was actually more stable. And so it's going there. It's going there. It's like, oh, yeah, I remember now. Dinosaurs, how are they doing? It's not exactly like that. It's not like it has a mind. It's not Gaia. It's not a goddess. Okay, it doesn't hate us or love us. It's physics. It's physics. It's mathematics. It's the physics of mathematics. It's whatever. It's black holes. It's quantum theory. It's all these things. It's physics. Okay, and the landscape in which all of this plays out, the stage where this play is acted out, is so far beyond our comprehension that there aren't even words. We are just a two-dimensional space on which the entire drama of the Earth system dynamic plays out around us like a shadow cast upon a wall of something of something with billions of gears. A shadow of that cast upon a wall. And when it starts to move, the only experience you will have of that as it liquefies and atomizes and flows across its own landscape that it understands in multidimensional phase space, that it remembers. And your only experience of it doing that will be the shadow we call violence. This Earth is going to become violent. And then one day, 100 years from now, or 200 years from now, or I don't know, 20 years from now, I don't even know how fast this happens. Could happen very quickly. It stops being violent. And when it stops being violent, that's its language for I have arrived. And you won't see anything different. The continents will be smaller and the sea will be higher and the ice will be gone. There'll be a bunch of other changes, but the Earth is still going around the sun and we still have an end, a year, and there's still 24 hours in a day, or however we're measuring it at that point, if we even bother. And you'll go, phew, things have finally settled down. That's nice. But that's what's happening to us. We did that. Turns out it was easy. Because that landscape is attractive. It wasn't hard for us to set this thing in motion. It remembers. And it's going back. It's going back. Yeah. It's going back. What the hell are we going to do?